This presentation is going to go through an introduction to accelerated bridge construction. So you can add whatever course you're teaching and your name to this title slide. This slide contains several different sample learning objectives that you can use for this presentation. You can see we highlight some of the learning objectives from Bloom's taxonomy here. So with an underline and italic. The outline of this presentation, we start with a background on bridges and ABC. Typically in my classes, before I can talk about ABC, I need to introduce what a bridge is. So we give you a couple slides on that. Next, we have the primary drivers or benefits of using ABC and some of the metrics for evaluating the effectiveness of ABC. Next, we have different categories that are used to classify ABC methods and techniques, and this includes prefabricated bridge elements and systems. And then finally, there are a number of slides based on example projects with PBES for ABC. So we'll start by going through some of the slides on the background on bridges and ABC. Here on the first background slide, we give you a general definition on a bridge and also the definition from AASHTO LRFD bridge design specification. So we also give that here. Then a list of possible obstacles that the structure is providing passage over and kind of a diagram to help you show where the obstacles will be located and some of the traffic and other things that might be passing over those obstacles. On the next two slides, we highlight some of the primary components of a bridge. We had some discussion on how to break these down, whether to do superstructure, substructure, or foundation, or just superstructure and substructure, and landed on just the kind of the common nomenclatures to break down into superstructure, which is it consists of all the components that span the obstacle, so all the components that provide the horizontal span from the AASHTO definition. And substructure, which consists of all the parts that support the superstructure, so everything beneath the horizontal span. The next background slide here has some key statistics about why ABC is important. And some of those reasons are based on the total number of bridges in our inventory. So there are over 617,000 publicly owned vehicular bridges in the US. The age of those bridges, a large chunk here, almost 40% being 50 years or older, and the cost, 125 billion needed just to rehabilitate the nation's aging bridges. So you can see some other information here, and the information statistics here are taken from the ASCE 2021 infrastructure report card. So we give you a link to that there as well. This slide gives a general definition for ABC. So essentially ABC, it involves the use of innovative planning, design, materials, and construction methods, ultimately to reduce on-site construction times. So this is the main goal of ABC. There may be other benefits, but this is ultimately the main goal. And you can see the definition here provided from the AASHTO LRFD guide specification for ABC. One of the main ways for accelerating construction is using prefabricated bridge elements and systems, or PBES. So I highlight that on this slide with an example project in Florida here. But you could get other example photos from a project in your state through the ABC project database. In the next few slides, we're going to go through the primary drivers or benefits and metrics for assessing the successfulness of an ABC project. The primary drivers or benefits for ABC and a number of the different keywords that, or I guess all the different keywords that I'm going to go through in the next number of slides, they were developed in collaboration with the AASHTO Technical Committee for Construction, T4, and FHWA. So thank you to them for their help in developing these drivers and keywords and definitions. You can get a list of all the drivers and keywords and everything by going to the project database keywords page, and I give you a link at the bottom of this slide. So in general, the primary drivers are listed here. You can see that the first two here are reducing traffic impacts and reducing on-site construction time, but there are a number of other ones listed here. So safety is a big one, reducing initial cost, reducing life cycle cost, are just some of the ones to highlight here, and also improved material quality and product durability. So there are many reasons that ABC is used and why it's beneficial to bridge construction in general. The four main metrics that are used to evaluate the effectiveness of ABC are shown here. So we have the overall project time, project development time, on-site construction time, and the mobility impact time. When we think of ABC, we mainly think of our mobility impact time. So we reduce the time that our traffic flow is impacted by on-site construction. So that's typically what we think of with ABC, but we can also accelerate these other time metrics. So for an emergency replacement, if a bridge gets wiped out due to a flood or fire, something like that, or a bridge hit, then decreasing the overall project time becomes, one of the more important parameters. Because mobility impact time is the most important metric with ABC, there are 6 different tiers that were defined, so shown here. So tier 1 is when traffic impact is less than 24 hours, so within a day, and that steps up and increases until tier 6, where in tier 6 there's no specific time or explicit time metric. It's just that the overall project schedule was significantly reduced by months or years compared to conventional construction. The bulk of this presentation is going to be focused on the categories of ABC and including prefabricated bridge elements and systems. So that's where we're going to go now in the presentation. There are 3 main categories of ABC techniques, so everything's classified into one of these 3. There's project planning, geotechnical solutions, and structural solutions. And there are keywords and subcategories for each of these main categories. So we're going to go through those on the next slide, or next slides. Here we can see different decision-making tools that can be used in ABC projects, different site procurement and project delivery methods. And there are several links here provided to different FHWA documents that are useful for some of these keywords. Here we also have different contracting methods that can be used in ABC projects. So kind of in summary, and I'm going through things quick. So depending on what the focus of your class is, you can spend more time in different areas. But anyway, just the main takeaway is ABC can be used with a variety of different contracting methods. And also, because ABC is a lot of it's construction focused, so there's a large benefit to involving the contractor early on in the design process. So you can find a lot of additional details here on this FHWA website. For each of the categories and many of the subcategories, I'm going to provide a list of suggested webinars and web training events that are available through the ABC UTC. And the first 2 shown here are kind of a state perspective on project planning. The first is in Vermont and how they kind of programmatically implemented ABC. And the second is Connecticut and how their DOT decides whether to use ABC on different projects. So you can go to these links if these topics are interesting to you. The next webinar that I'm highlighting here is FHWA's webinar on bridge bundling, or their bridge bundling guidebook. And with ABC projects, it's often better to group a number of bridges that have either similar characteristics or maybe they're in a similar geographic region, and to let them out as kind of one larger project. So FHWA talks a little bit about that here in this webinar. This webinar highlighted here is about ABC and risk and a contractor's perspective on the risk associated with ABC projects. Uh, there's often, incentive and disincentive clauses that are built into some of the ABC contracts to try to incentivize contractors to complete a project in 24 hours, and then they'll add charges if the project goes over, a charge per hour if a project goes over that. And contractors build that risk into the bid. So it's a good webinar kind of discussing some of that. So, you may have some of these disincentive or incentive disincentive clauses built into the or in the into the contract, but the contractor will increase their price. So it's a worthwhile thing to think about. So that's a good webinar for that topic. Our next main category is our geotechnical solutions. And here you can see two of the subcategories. So we have foundations and walls and rapid embankments, and some different options in each of these categories. So foundation work, we typically want to try to do as much of the foundation work before the superstructure replacement, or we want to try to reuse or repair and retrofit and reuse the foundation. The foundation work can be one of the more time-consuming aspects of a bridge project. So if we can do that before closing traffic, it'll greatly accelerate or it'll greatly decrease the mobility impact time. So here are two webinars that kind of talk about different geotechnical solutions. The first is looking at foundation reuse for highway bridges. So when you can reuse the foundation and substructure elements, and how you evaluate when you can use it. And then also the second here is on high capacity micro piles. So if you have limited overhead clearance, like you're trying to drive piles under a bridge, you can use these micro piles to help with that. So this is one solution, using these micro piles kind of under the existing superstructure. You can also use conventional piles and kind of drive them outside the footprint of the bridge, and then use like a post-tensioned pile cap in between the two. But anyway, this webinar is on high capacity piles, so you can go and see more information on that in that webinar. Next, we're going to look at structural solutions, and this will be kind of the bulk of this presentation. And these are the kind of the most common techniques that are used in ABC projects. So we have prefabricated bridge elements and systems. Elements are single structural elements, and systems would be the entire superstructure. And some of the benefits, these can be built off-site or adjacent to the alignment, so close to the site, so they can be built without impacting traffic. So this allows us to decrease our on-site construction time and decrease our mobility impact time. There are a number of different categories of prefabricated bridge elements and systems as listed here. We have deck elements, deck beam elements, full width beam elements, pier elements, abutment and wall elements, and buried bridge elements. And you can see some examples of some of those shown here, where all the photos are taken from the ABC project database. On this slide and some of the following slides, we'll have some of these subcategories and some specific types of that subcategory. So here, the deck elements, we have these specific types of deck elements, with the full depth precast deck panels being the most common. And you can see some example projects from the ABC project database listed aside. So here we have the deck elements, we have our deck beam elements, and some examples here. So the most common deck element is our full depth precast deck panels. And here's an example from Iowa. And you can see two pictures with our shear pockets and our connection pockets for connecting the post-tensioning tendons that attach these longitudinally. Another example of full depth precast deck panels are shown on this slide in a kind of a rural setting on a steel arch bridge. The next two categories of prefabricated elements are full width beam elements, shown here, and these are essentially full width beam elements without the deck. If it has the deck, then it becomes a prefabricated system. So here we have a truss span without a deck falling here. And then we also have some pier elements, so precast pier elements and substructure elements here. Various prefabricated abutment and wall elements are shown here, and these are often used in ABC projects where you need to replace the substructure after traffic is moved. And here's the last category of prefabricated elements, the buried bridge elements. So here you can see a precast three-sided box during construction and after the bridge was open to traffic. The element of most interest nationwide is our modular decked beams. And here you can see a next beam, and this is one of the popular modular decked concrete beams. Here is an example of a steel beam. So we have a concrete decked steel beam where the concrete deck is with two adjacent steel I-beams. Shown here are two related webinars. The first is a webinar where it goes over the full depth precast concrete deck panels in their typical configuration. And this webinar really talks about why FDPC deck panels are a good choice, not just for ABC, but because of durability, or improved durability and decreased cost. The second webinar here looks at FDPC deck panels kind of in a different configuration. So here we have the panels in the oriented in the transverse direction, so the full bridge width. And here they can also be oriented in the longitudinal direction. So this is what this project looks at, the Boston's Commonwealth Avenue Bridge. Here we have two additional webinars. So the first is looking at modular decked beams. And this webinar offers a solution for differential camber, where the girder is precast, and then the girders are all taken to the bridge site and placed next to each other, kind of on temporary supports in the configuration that they'll be in on the actual bridge. And then a deck is cast on each girder in that final configuration. And this kind of this allows the deck to be cast, taking into account the differential camber. The second webinar here looks at next beams, which is a common deck beam element that's started in the Northeast, but now it's being used around the country. The next webinar here is an in-depth web training from 2014 looking at Massachusetts DOT's 93 Fast 14 project. So this was a larger scale project, replacement of 14 bridges, and there were many different prefabricated elements used in this project. Next, we have a precast cap solution, so pre-tension bent caps used in Texas. And this is kind of more of a standard or a typical precast cap that can be used. And then here is a webinar on buried bridge elements, just from April 2021. The next two webinars shown here that have kind of more unique precast elements. So the first one here, the Bronco Bridge, has some unique substructure elements and curved U-beams. And then the third or the second webinar here has some unique substructure elements. So these two projects are here to highlight that ABC can also be used in aesthetically pleasing bridges. So aesthetics can be a factor in ABC bridges. The next category of structural solutions is miscellaneous elements. So this category includes different miscellaneous structural elements, and then also our closure joints and connections. So some specific materials used in closure joints and other materials used in connections and types of connections. And then also we have overlays falling under the miscellaneous elements. So different overlays can be used in ABC projects as shown here. Many different webinars involve connections or miscellaneous elements, but some of the ones that we're highlighting are shown here. The first is a webinar looking at precast approach slabs, UHPC closure joints, and an overlay here with a PennDOT SR30 over Bessemer Avenue. The next, we have a project where a lightweight concrete deck was used. A lot of times in ABC projects, we need to minimize the weight of our superstructure, either if we're reusing a foundation or using SBMTs or something where or cranes to decrease the weight of placement. So we can use lightweight concrete to decrease the weight of our superstructure or our prefabricated elements. And this is one example webinar where they used a lightweight concrete deck. The next webinar shown here has link slabs and an overlay. So link slabs are a common ABC technique. So this webinar talks more about that. And then this webinar here for a project in Delaware used all precast elements, and they used ultra high performance concrete in the closure joints. And then they also used a UHPC overlay. So it's an interesting webinar for UHPC closure joints and overlay. Our next subcategory of structural solutions are prefabricated systems. So prefabricated systems include the structural components and the entire deck. And these can be the superstructure system only. So like I said there, that would be the whole superstructure, beams and deck. They can include the superstructure and substructure system without the foundation, or also a total bridge system, which would include or which would be placed on shallow foundations. So these can be rolled or launched or slid or lifted, and these techniques help to really reduce the mobility impact time. So if mobility impact time was within 24 hours or something like that, or 3 days, typically we have a prefabricated bridge system being used. And shown here are 4 different example projects. So as I said, a prefabricated superstructure system includes both the deck and the primary supporting members. So if the deck's not included and it's just the supporting members, then it would fall into the prefabricated elements category. But when you add the deck on there, then it's in the superstructure systems for the full bridge superstructure. So here are a couple of examples of prefabricated superstructure systems. This slide shows some of the subcategories and definitions for prefabricated superstructure, substructure systems, and prefabricated total bridge systems. These are more of an emerging technology, so there haven't been as many projects using these, but there is a webinar that highlights the use of a prefabricated super and substructure system without the foundation. So I'll give you a link to that project shown there. The systems of most interest in terms of prefabricated systems are prefabricated superstructures moved with self-propelled modular transporters, or SPMTs, or prefabricated superstructures using lateral slides, using either hydraulic jacks or winches. So shown here are some examples, and just highlighting that these system moves can be single span, but they can also be multi-span. So you can use here's an example of a 2-span SPMT move, and in these 2 examples we have a 3-span and even a 5-span lateral slide. So here are some webinars for these different technologies using prefabricated systems. The first here is a concrete deck with steel beam that was moved using SPMTs. So this was just a kind of a simple bridge, that was done by PennDOT. So SPMTs can be used in simple projects. Here we have a concrete deck with concrete beams that was placed using a lateral slide. And this project had an integral abutment connection with UHPC. And this project was, we actually implemented an ABC UTC research project into a bridge project. So that was some research done by Iowa State University. Here we have two additional webinars. The first is a full truss superstructure that was slid into place using a lateral slide, and this was for a railway project. So very large spans and large superstructures can be placed using lateral slides or SPMTs. And here is a concrete deck with steel beam superstructure. And this superstructure had a large skew and also curved beams. So, you know, the SPMTs can be even used with skewed or curved beams. Here are two additional examples. The first is a concrete deck with steel beam. And in this project, it was interesting because they took two kind of separate two beam bridges, they slid them apart, and they added some bracing in between to make one 4-beam bridge, and then they added some lanes in between. So just an interesting use, a kind of reuse of a current superstructure system, and to add some redundancy and add some capacity with additional lanes. And then the last webinar here is a super substructure system without foundations. I highlighted this a couple slides ago, but this is kind of an emerging technology, so an interesting webinar. We already mentioned some construction equipment or methods, but another subcategory of our structural solutions is construction equipment and methods. So here we have our SPMTs and our lateral slides, and the SPMTs can be on gantry or even on barges, and lateral slides, they can be on pads or rollers. So these are some of the subcategories shown here. Here are two additional subcategories for construction equipment and methods. The first are longitudinal launches, and other equipment can be used as well. So oftentimes our prefabricated bridge elements can be very heavy and require high capacity crane. And also if you're working over waterways and things, then you can put your cranes on barges. So those are a couple commonly used techniques. Two webinars to highlight that kind of highlight more construction equipment are shown here. The first is an in-depth web training on lateral slides, and this was the Milton Madison bridge replacement. This was one of the biggest lateral slide projects done. So there's a 4-hour in-depth web training on that you can go to if you're interested. And the next one here is on SPMTs. So this was an interesting project because they used SPMTs on barges. So it shows how you can kind of use SPMTs and barges in a ABC project. So you can go to that webinar for more information on that. On the next slides, there are several examples of prefabricated bridge elements and systems for ABC. So example projects. And this section, the content of it was based on slides developed by Mary Lou Rawls Newman. I'm not going to go through all these examples just because of our time limitations for this session. But if you're interested in these examples, feel free to use them and use the examples that are relevant to your class and modify them as needed. In general, these example problems will have one slide with some detailed information on the background of the bridge, the location, and some details on how long the closure was. They'll include the primary reasons why ABC was used on the project. They'll also include what kind of precast or prefabricated elements were used, and some of the other details on the ABC. So here are some details on the closure joints and the non-shrink grout. And finally, they'll also typically discuss some of the other ABC techniques or technologies that were used. I hope that this presentation is useful for you and that you're able to integrate some of it into your class. Feel free to reach out to me if you have any questions or any suggestions on modifications to the presentation. So thank you.